Hello everyone, welcome back to our lecture. As we continue our topic index property, let's start with the new topic. We can learn today about Atterberg limits, which is liquid limit, plastic limit and shrinkage limit. So be patient and take a look. The Atterberg limits. Consistency is the relative ease with which soil can be deformed. It is applicable to fine grained soils whose consistency depends on water content. Obviously, the fine grained soil it has a finer particles like silt and clay. Silt and clay has minerals which can react with the water. Now, relative consistency can be expressed as very stiff, medium stiff, soft and very soft with increasing the water content into the soil mass. So here you can see the figure with some functional things. The graph plotted here is of water content versus volume. In ordinate it is a water content, in Africa it's a volume. For a certain volume, a material is considered as a solid, okay, up to the shrinkage limit. If we can add some amount of water, then this solid particle is converted into the semi-solid soil mass. So that here we can see the increment in volume. At the shrinkage limit, the volume is up to here, and for the semi-solid sample, it is up to here. After increasing the water content, a soil sample is reached up to its plastic limits. Now, further increment in water content will also increase further increment in volume. So the sample will become semi-solid to plastic state. Here the maximum amount will be of water added is considered as liquid limit. Up to the liquid limit, if we add the more water, then soil itself behave like a fluid. And similarly, the water content less than the shrinkage limit, the soil particles starts to be crumble. In simple words, we cannot able to make a mold if the water content is less than the shrinkage limit. Generally, we can make a clay toys or clay molds by using a moisture content up to the plastic limit. Here, basically, the Atterberg limits are converted into the three types: liquid limit, plastic limit, and a shrinkage limit, as we seen into the figure. A liquid limit is the arbitrary water content between plastic and liquid phase of soil. It is the maximum water content in the soil where it behaves as a plastic material. A liquid limit is the amount of water into the soil where the soil contains least amount of shear strength. If we add a further amount of moisture content into the soil sample, it will reduce all the shear strength if we increase the water amount more than the liquid limit. Then next one is plastic limit. A plastic limit is the maximum water content in the soil at which a thread formed by the rolling on a glass plastic crumbles at 3 mm diameter. In simple words, we have to roll a soil sample to the glass plate, and how much thinner we have to roll that soil sample is a 3 mm diameter. If it will break at 3 mm diameter, then we have to take that soil sample and put it into oven dry. In other words, it is arbitrary water content between plastic and semi-solid state. Now, shrinkage limit. A shrinkage limit is the maximum water content at which soil behaves as a solid material. It is the maximum water content below which decrease in water content result in no change of volume of soil. In simple words, if we decrease a further amount of water, it will not result in any type of change in volume of the soil. Okay, at shrinkage limit, the reduction of volume of soil will be stopped. A shrinkage limit, it is arbitrary water content between solid to semi-solid phase of soil. Now, let's try to understand and the determination of liquid limit test. To determine the liquid limit of the soil, we can use the Kasagand liquid limit apparatus. Into the figure, you can see here exact model of Kasagand apparatus. Here is the Kasagand grooving tool. This is the dial numbers. This hand is used to blow up this bowl. Now, let's take a look for the determination of liquid limit using Kasagand liquid limit apparatus. What we have to do to determine this test? First of all, we have to take 120 gram of air dried soil sample. After passing through it, form 425 micron of sieve. Arbitrarily mix certain amount of water and make a paste. We have to take a water content randomly until it will become a paste. Put the soil pad in the brass cup and make a V-shaped groove using grooving tool, which I show you in the figure, which is called Kasagand grooving tool. Give blows at the speed of 2 rps till the groove closes up to the 10 mm or 1 centimeter. Count the number of blows at the end of experiment. That means we have to continue our blows until the grooving surface will be a separated grooving surface will be into the contact of each other up to 1 centimeter. After 1 centimeter of contact, we have to stop blows and note down to reading from the counting machine. Now, take a certain amount of soil from the cup to determine the water content using oven dry method. Take at least 5 numbers of trials with varying number of blows from 15 to 35. This corresponding water content at 25th blows is taken as a liquid limit. To determine this 25th blows, we have to make a graph. Here is the sample of graph, which is the graph of number of blows versus water content. Water content which is determined from the different sample taken throughout the test and using oven dry method. Now for the 25 number of blows, after getting a different number blows for the different water content, we can get a linear downward line or downward curve. Now for the 25 number of blows up to the curve, we have put a one line and attach it with the water content. When the line touches to the water content, at that point we have to take a reading, which is actual liquid limit of the soil sample. Now take a look to determine the plastic limit of soil. Plastic limit of soil, we have nothing to do, but only we have used a glass plate. To determine the plastic limit, take about 15 gram of air dried soil after passing it through 425 micron of sieve. Approximate mix a certain amount of water to make a soil balls. A soil ball similarly looking like this into the figure. Roll the soil balls on a glass plate with the palm by applying negligible amount of pressure. Make a thread till it attains a thickness of 3 mm. To determine the thickness of 3 mm, take 3 mm of rope inside of your test. If the thread crumbles at a 3 mm thick, then take sample to determine the water content, so that if your sample is break at the 3 mm, you have to take that sample and put it into the jar. Then jar you have to put into the oven dry. Now corresponding water content after the oven dry method is taken as a plastic limit of that particular soil. Now determine the shrinkage limit of the soil. To determine the shrinkage limit of soil, you require this type of equipment you can see in the video. First of all, to determine the shrinkage limit, we have to take 30 gram of air dried soil after passing it through 425 micron of sieve. Soil is mixed with sufficient quantity of water so that it may flow. Fill the soil mix in dish and take the weight of dish. The soil pad is allowed to dry in air till the color of pad changes from dark to the light. The dish is then placed in oven at 110 degrees centigrade till it attains constant weight. The shrinkage dish is weight with the dry soil and dry weight of soil is determined. The volume of dry soil pad is determined by mercury displacement method. Now take a look of the figure here. First of all, at the original soil bed, which is behave like a fluid. In that soil sample, this is the weight of soil which is denoted by Ws, and this is the total weight of soil sample in which it is a soil solid, and weight of water which is considered as W1. Here is the volume 1. Here the soil pad at shrinkage limit, there is some negligible amount of water, so that the total volume is V1 and here it is considered as a V2 because reduction in moisture content. The volume of soil sample is reduced to the V1 minus V2 up to this to this. Here similarly the weight contents are same weight of soil samples, and it is the weight of water, and the total weight is denoted by W2 for the shrinkage limit soil pad. After the oven dry, the soil sample will become alone and there is no moisture available into that soil pad, so that the volume is considered as the V2 only, and the total weight is similar to the weight of soil solids, because here no weight of water is available. Here is only weight of air, and you know that the weight of air is equal to 0. We can learn it in three-phase diagram soil system. Here from the figure, V1 is equal to volume of container in which plastic phase soil is filled initially. W1 is weight of wet soil sample along with the container. V2 is equal to volume of soil at shrinkage limit. W2 is equal to weight of soil sample at shrinkage limit. Vs is volume of dry soil pad, and gamma W is unit weight of water. A shrinkage limit is nothing but a water content at a particular case. For example, weight of soil solids. Ws is equal to Ww over Ws into 100, which is similar. The equation is similar as the moisture content equation, where the water content is equal to weight of water over weight of solid into 100. Guys, here to determine the shrinkage limit, the weight of shrinkage limit will be the count, where the weight of water at the shrinkage limit is W1 minus Ws bracket close minus V1 minus V2 into gamma W. Hence Ws is equal to W1 minus capital Ws bracket close minus V1 minus V2 gamma W over Ws. So put this all values into this equation, we can able to determine the shrinkage limit of the soil. So guys, we complete our lecture today here. Today we learn about the ATTERBERG limit of the soil, which is liquid limit, plastic limit and shrinkage limit. Here you can understand the definition and the practical procedure how to determine these limits. So if you don't understand, take a look once again and comment me below. Thank you for listening me. We complete our lecture here. See you into the next lecture with new topic.